Hello, my name is Beth Dixon, and this video is part 4 of a video series on basic probabilities and discrete random variables. Thanks again to Vicki Borlaug for the use of her PowerPoints on this video. And we're in the middle of an example on a family having 3 children and finding some discrete random variables. And I'm going to go backwards just for the convenience so that you remember where we're at. We have a probability distribution created, and we are going to pick up from there and answer a question about that probability. And that question is to find the probability of having exactly one boy. And instead of using our sample space, the first way we're going to do this is just to look at the table. To find the probability of exactly one boy, again, notice our notation, P for probability, exactly one boy in the parentheses, shortened versions of the words needed to explain what we're looking for. And from the table, we see that our answer is 3/8 or 0.375. This row represents getting exactly one boy. Generally, you'll want to box in or circle your answer to make it easier for your teacher to see it and to find your answer, because if you've got a table and you're writing your answer, if your teacher doesn't leave you a blank, put your answer in, box your answer in. Okay, we could also have gotten this from the sample space. Since the events are equally likely, we've got our sample space here, and we can count then which of these have exactly one boy in the group. Doesn't matter the order, so that gives us 3 of the outcomes of the 8, which gives us 3/8 or 0.375. Looking at part D tells us to find the probability of having at least one boy. Think about the phrase at least one and what that means. It means you can have one boy, at least one boy, could also be 2 boys, or 3 boys. If I ask my son to do at least one load of laundry, he needs to do one, but I might prefer him to do more. So at least one means one or more. This is because in a family that has 3 boys, you do have at least one boy. In a family that has 2 boys, you do have at least one boy. So to find the probability of having at least one boy, we need to look not at one row, but at the rows with 1 boy, 2 boys, and 3 boys. And we can count or add up those probabilities. 3/8 plus 3/8 plus 1/8 equals 7/8, or adding the decimals here, we get 0.875. Okay? We could also do that using the sample space. At least one boy. Which of these have at least one boy? Well, if we look at it, we have at least one boy in all of the groupings except the last. How many will that give us? 1, 2, 3, 4, 5, 6, 7 of the 8 in the sample space, which gives us 7/8 or 0.875. Next, we'll look at part E. Find the probability of having at most one boy. Finally, I don't know why I said finally, just come out of my mouth. So, again, we want to pay close attention to the wording. These are our directions, And in probability and statistics, this course is a language-based math course, and the language leads us to what to do. So what does at most mean? Well, the probability of having at most one boy means that the most we can have is one boy, but less is okay. So having no boys or 0 boys, either way you want to word it, is okay, or just having one boy is okay. So let's look at which of the rows meet those criteria. Well, that would be these 2 rows. And that would give us 1/8 plus 3/8, which is 4/8, or adding the decimal and changing 4/8 to a decimal, we get 0.5. Now, before we look at the other way to do this, let me do as an aside a way to help you keep straight the mathematical phrases at most and at least. I like to use the example of going to the movies. I can go to the movies if I have at least $6. Now, that's assuming I'm going to the matinee, of course. I can go to the movies if I have $10. I can go to the movies if I have 12 or even more dollars. Yes, I can go to the movies. Can I go to the movies if I have exactly $6? Yes. Can't get popcorn, but I can go to the movies. Now, can I go to the movies if I have $4? No. If I have $5.99? No. Not unless I find another penny. Now, that means I have to have 6 or more. So at least means that number or more. Now the next statement, and the way I like to say this, is I can take at most 6 people with me to the movies because of the number of people that my van seats. I can take no more than my van seats to the movies with me. I can take one person in the van. I can take nobody with the van. I can go by myself. I can take 3, 4, 5, 6 people with me. But I cannot take 7 people with me to the movies because there's not enough room in my van. So when I say I can take at most, that's the largest, but anything less than that is okay. I hope that helps clarify those 2 phrases, because we will be seeing those quite a bit in the next part of your course. And again, back to what we were saying, we've got our answer here, and let's look at the other way to calculate that. To find the probability of having at most one boy, we look at the list and just figure out which one has 1 or fewer boys, and that would be those 4 there, which would give us 4/8 or 0.5. Now we have an exercise, and in this exercise it's an example just like what we have just completed in part 3 and now in part 4 of this series, and gives you a chance to do it on your own. I will give you enough time and enough area to pause the video so that you can look at this and try this on your own, and then I'll give you some answers for this as well. I hope this video has been helpful, and thank you for watching. Pause now. Usually I give the answers to the exercises in the next video, and in this case I'm not going to give the answers to part A and B because they're so visual, and you will need and Ms. Borlaug sometimes gives those as quiz questions. But feel free to come by the math lab or contact me by phone or email for help with those. If you get parts C, D, and E correct, then you probably have parts A and B correct. Part C is 3/8 or 0.375. Part D is 7/8 or 0.875, and Part E is 1/2 or 0.5 or 0.50. And again, thank you for watching.